So before anything else, let me introduce to the topical workbook for computer science 2210 or 0478. This is the workbook 1 for paper 1, basically computer systems. And as you can see from the table of contents, I've included questions on each and every subtopic from the syllabus along with the mark scheme. And these are some of the actual questions, actual pages as a preview from the workbook. Section 1.1, 1.3, 2.2, 3.2, 5.3 cybersecurity and artificial intelligence. This is just to show you a glimpse of what type of questions are included in the workbook. There are many more questions where these come from, and around 18 to 20 questions on an average are included for each and every topic. A must buy if you want to boost your grade. Similar to the paper 1 workbook, I have designed a paper workbook for paper 2 as well. This is for algorithm, programming and logic for CAIEs either 2210 or 0478 GCE or IGCSE Computer Science. As you can see, it contains questions on every subsection of the syllabus content for paper 2 along with the mark scheme, so you can understand each and every question, each and every algorithm. These are some of the few pages from the workbook just to give you a glimpse of what type of questions are included. As you can see, this is 7.1, this is 7.7, 8.3 and section 10 Boolean logic. So a lot more questions are included in the workbook. A must buy if you want to have a very good score in your Cambridge examination. Order now. Assalamu alaikum warahmatullahi wabarakatuh. Welcome to another physics lecture. So we were discussing section 4.4 practical electricity, and we had discussed till the dangers of electricity. So now today we'll start with the safety measures that you can take in order to protect yourself from the dangers of electricity. The first one is supposed to be to use a fuse and circuit breakers, or they are also known as trip switches. In order to prevent excessive current flowing into the home circuit, electrical appliances and its cables, fuses and circuit breakers are wired into the live wire. They are used as safety devices. What is a fuse? A fuse is basically made up of a very thin wire of that is of tin, and it has a light coating of copper onto it to make it conductive. When the current exceeds its designated value, then the wire heats up and burns out or melts. Hence the circuit is broken and the excessive current does not get to the actual appliance, saving your appliance from burning out. One fuse can only be used one time. Once it has melted away, you cannot reuse it. Here's a picture of a fuse. It works on thermal and electrical properties of the conducting material, whereas this is what a circuit breaker looks like, which works on the switching principle and electromagnetism. Now a few pointers to keep in mind. A 3 ampere fuse will be needed for appliances with powers up to 720 watts, and for a 13 ampere for those between 720 and 3 kilowatt. Now these are different ratings for different countries, so you don't really have to remember that 3 ampere fuse is red, 13 ampere fuse is brown. Remember, if you have to calculate what type of fuse should be used in a circuit, then simply calculate the power of that circuit, or either the power would be given to you Basically what you need to do is you need to not the power, basically you need to calculate how much current would be flowing into that circuit. For that, most of the time you will be given the power rating of appliances. Just use them, put them into the formula P equals to IV in order to find the value for the current. Now whatever value of current you find, let's suppose you get something like 5.3, always remember that the fuse that you would use would be about 10 to 20, should be 10 to 20% more than whatever value of current you get. Means if an appliance works on 5 ampere current, by the help of power you calculated that it would work on 5 amperes. Then you would use a fuse of 5.5 or 6 amperes, so that the device or the appliance would be easily able to obtain its maximum amperage, its maximum current from the circuit. If you get a rating of 5.5 ampere and you write down that use a fuse of 5.5 ampere, this would mean that as soon as the appliance would start drawing current from the circuit, a current of 5.5 ampere, the fuse would trip and the appliance would not be able to start at all. So always remember this general tip. You need to use a fuse that is around 10 to 20% more current rating than the amount of current that would be flowing through that appliance or the circuit. Calculation of power in a device allows the correct size of fuse to be chosen. A circuit breaker. Now what is a circuit breaker? A circuit breaker is usually made up of a reusable spring-loaded switch. The function of the circuit breaker is similar to that of the switch. If the current exceeds its breaking settings, or if the current exceeds its certain designated value, the switch trips and the circuit closes down, so the appliance does not burn out. And once you have turned off the excessive current, or you have taken care of the short circuit or whatever was the problem with the electricity, you can simply push the button back up and the trip switch or the circuit breaker is good enough to be used again until there's another incidence of over excessive current flowing through the circuit. It is a trip switch or a circuit breaker is basically reusable. You see this, once some excessive current flows in, this automatically falls down. And once you have taken care of the damage, you can simply push it back up and the circuit would work fine. It would again be, the switch would again be closed and the current would start flowing again. It is correct to fix the fuse or circuit breaker at the live wire. Always remember, circuits or switch breakers are connected on the live wire, never on the neutral wire, and they are connected before the appliance so that excessive current can trip them and does not damage your costly appliances. When the circuit is loaded with excessive current, the fuse or circuit breaker will break, preventing overheating, overloading, burning, etc. Connecting the fuse or circuit breaker to the neutral wire is incorrect. This would not save your appliance from being burned out, because then the excessive current would be able to pass through your appliance and then it would reach to the fuse or the circuit breaker. The circuit breaker or fuse would still trip or cut off the current, but by that time it would be too late. Your costly appliance would be a pile of ash, or you would have already gotten an electric shock by then. The current limit through the fuse, a fuse rating, can be controlled by varying the thickness of the tin coated copper wire. If you want a fuse of higher power rating, you'll simply increase the thickness of the fuse. The more thick it is, the more power rating it will have. Different fuse ratings and circuit breakers are used in different appliances. Depends on how much power would an appliance draw out. The rating limit used is normally slightly higher than the normal current needed by the appliance. What we just discussed, that it should be 10 to 20% more. Another safety measure is earthing and double insulation. Earthing is the act of connecting the metal casing of the appliance to earth via wired connection to the bare ground. Earthing wires are they usually have a green and yellow color, but then again it varies from country to country, so learning these colors isn't really important. You don't have to learn them by heart. Now what you do need to know, that why do you need earthing? The live wire is frayed. For example, the live wire has faulty insulation and it touches the metal casing of your appliance, a laptop, a microwave oven, a washing machine. Now the appliance has become live. The outer casing of the appliance is metal, so now the current is flowing through that conducting surface. And if the appliance does not have any earthing cable, the current would keep on falling through it, the outer casing, and when anybody touches it, the current would flow into your body, as your touch would complete it, as your touch would give it a path, that okay, the current would be able to flow through your body and go into the ground, completing a circuit, and a large amount of current would pass through your body. The current is not high enough to this current would not be high enough to trip a fuse or a circuit breaker. Hence you would get electrocuted. If you have earthing, if you have connected the metal casing to the ground, then the current will have two paths to choose from. Either the current would go through your body and get into the ground, but your body would have a higher resistance, or it can directly pass through a small wire having very low resistance and go into the ground. So by default, the current would always choose the path that has lowest resistance in order to flow. Hence you will not get electrocuted. No current would pass through your body, but all the current would go towards the earthing wire and would go directly to the ground. Hence you would be saved, and there would be no incidence of electrocution or electric shock. You can identify which appliances have an earth wire by checking their plug. Appliances which have earthing wires built into them, installed into them, have 3 pins in their plug. The bottom ones are live wire and neutral wire, whereas the above one is supposed to be the earth wire or the earthing wire. And all these 3 pins should be made up of metal. Some cheap appliance companies, what they do, they apparently make 3 pins in their plugs, but if you look closely you would find these 2 are metal, whereas the top one is of plastic or some other insulator. That does not make it a insulating wire, or that does not make it a not insulating wire. That does not mean that your device is having an earth wire. For having an earth wire, all 3 pins must be metallic. Now another way of preventing electrocution or dangers of electricity is to use double insulation. Well, technically this is the third and the last method. There are some appliances which do not have an earthing wire. Instead, what they do, they use double insulation. Double insulation protects the user from an electric shock by preventing any possibility of the external casing becoming live. How do they do that? There are 2 layers of insulation. The first insulation covers the electrical wire from the main, and it separates it from the it insulates the electrical cable from the internal components of the appliance, such as its casing, whereas the second insulation is inside the metal outer casing, so that even if a wire becomes frayed, it would only touch the insulating plastic, and that current would not be able to reach the outer metal covering. Here is a diagram which can make you understand. This is the 2-core cable from the mains. Both of the wires inside the cable, live wire and neutral, are insulated. As you can see, this is blue, this is brown. That means there is some rubber sheet or rubber covering onto it. Now let's suppose for any reason this becomes frayed, this becomes damaged, and the bare wire is exposed. Then here is the metal covering, and inside it there is a thick layer of plastic or rubber or foam. This wire, even if it touches the plastic, the current would not be able to pass through the plastic and reach this outer metal covering. So hence there is no need of earthing wire, as the current would never be able to reach the outer covering. This is known as the double insulation method. If the external casing is plastic, there is no way the external casing can become live unless you put your whole appliance in a tub of water. Then you would simply be stupid. I don't think so anybody would be stupid enough to do that, but that would technically be the only way to make the outer casing live. Electricity in houses. Electricity is supplied to the household via the mains. There are two wires. One is the live wire that is labeled as L. It have high voltage, that is approximately 220 to 240 volts, again varying from country to country. This is the wire that carries current into the house circuit. They are usually colored red. Then the other one is colored black, and this is known as neutral wire, labeled as N. It has zero voltage or zero current. That actually carries current back towards the main supply out of the house. They're typically colored black. Touching the live wire will give you a shock, but touching the black wire is safe. It would not give you a shock unless and until your wiring is faulty, and somewhere in the house the live and the neutral wires have merged together or they are touching together. In that case, even if you touch the black wire or the neutral wire, you would still get a shock. So if you are dealing with mains electricity or a household circuit, never touch any of the wires with bare hand, because you don't know when there might have been an incident of the two wires touching together. Current is carried into the house by the live wire through a main fuse, electricity meter, a main switch, and a consumer distribution unit. And then it is returned from the house via the neutral wire to the public power supply, whatever is your public power supply company. This is considered to be the complete circuit. Connecting an electrical appliance between a pair of live and neutral wire completes the circuit, and hence that appliance is able to draw power from the live and neutral wire and is able to work. A voltage difference from 0 to 240 volts is set up between the terminals of electrical appliance, resulting in a current flowing through the appliance. The electrical energy is then converted in the appliance into any other form of energy depending upon what type of appliance it is. Okay. Another thing that you should know, that household circuits, all the appliances in the household are always connected in parallel. The biggest benefit for that is, even if one of the appliances becomes malfunctions, they burn out or they need replacement, the rest of the circuit is unaffected. Current is still able to flow to all the other remaining appliances. If they were connected in series, if one appliance burned out, current would not have been passed through it and reached other appliances. So even if even a single bulb in your house would have burned out, then the electricity supply to your whole house, to all the appliances in your house, would have been cut off if your household circuit was joined together in series. So always remember, household circuits or the electric circuit coming to your house or that connects all the appliances inside your house is always made in parallel. Example questions: what is the unit for the energy used by an electrical appliance? Obviously kilowatt per hour. We do not have any other unit for that. Figure 8.1 shows a circuit containing a 230 volt AC supply. Here is the supply.